Movable pulley. A movable pulley increases the amount of force applied. It does not change the direction of the force, but it will halve the load. The formula here is force is equal to load divided by 2. This is our formula. Let's continue with an example. The formula was F is equal to load divided by 2. So I'm looking for the force in the section A. So force is equal to, what is load here? 400 Newton divided by 2, and that's equal to 200 Newton. So that means I need 200 Newton to lift this load. And the other half of 200 Newton is here as a tension. Tension on the rope. Okay. So let's look at this one. Again, I'm writing our formula. Force is equal to load divided by 2. But you can see here, I'm looking for the force, this one. Let's say the tension in this rope is T1 and tension in this rope is T2. So T1 is equal to F, and this one is also T2 because they have the same tension because of the load. So if load is equal to 2 times T2, and I know that from here T2 is equal to T1 plus F. Let's find T2. For 100 Newton divided by 2, and that will be equal to 200 Newton. This is 200 Newton, and that's equal to that because T1 is equal to F, I can say 2F here. So F is equal to 100 Newton. Block and tackle. A pulley system of both mixed, fixed and movable pulleys is called a block and tackle. And here the formula is a little bit different. Force is equal to load divided by number of ropes pulling the load. So we are looking for the highest number here. Highest number of, as you can see here, 1, 2, 3. The mechanical advantage is equal to number of, let's say, number of ropes. Okay, let's look at the example. So the formula was F is equal to load divided by number of ropes, the maximum number of ropes. We are looking for the maximum number. So the force is given as 50 Newton, and I'm looking for the load here. And what is the number of ropes? I will find the maximum number of ropes. Here we have 1, 2 and 3. So the number of ropes is 3. If I extract load here, load is equal to F times number of ropes, which is 3. So how can I find the mass here? Again, weight was equal to load, and that's equal to mass times gravity, and gravity was 10 Newton per kilogram. I can find the mass from here as load divided by gravity, which is 150 Newton divided by 10, and mass will equal to 15 kilogram. The mechanical advantage is in block and tackle was number of ropes, and here I found number of ropes as 3. Okay, first we found the load, which is 150 Newton, and then we found the mass, which is 15 kilogram. And finally, we found the mechanical advantage. Okay, let's continue with inclined plane. The plane with a slope is called inclined plane, such as ramps. It makes our job easy, especially if we are carrying a heavy load to raise. Let's see the example. Assume that we have a load of 100 Newton load which we want to raise 40 centimeter high from the ground. What is the force required to lift 100 Newton load by using an inclined plane? As you can see on the picture, force times force distance, and that's equal to load times load distance, which is height here. The force distance is equal to this one, which is 80 centimeter, and the load is 100 Newton, and the height, which is the load distance from here to here, exactly 40 centimeter. Force is equal to 100 Newton times 40 divided by 80, and force will be equal to 50 Newton. The mechanical advantage is 2. So what happens if we longer the distance? Again, force times force distance is equal to load times load distance, which is 40 centimeter here, and that's height. Again, I'm looking for the force. The force distance is 200 centimeter, and load is equal to 100 Newton again, and the height is same, 40 centimeter. So from here I can find force times 200 centimeter is equal to 100 Newton times 40 centimeter. I can find the force from here. 100 times 40 divided by 200 centimeter, which I can cancel out this one, and see, if I simplify this one, 1 and 5, and it will be equal to 100 divided by 5, and that's equal to 20 Newton. So from here I can find the mechanical advantage as load divided by the force, and load is same, 100 Newton divided by 20 Newton. You see, the mechanical advantage will be increased because I make the road longer. So I spent less energy. It was before, it was 50 Newton before, as you can see, and the mechanical advantage was 2. But if I make the road longer, well, it turns out that the force will be decreased because we make the road longer. Okay, let's continue with the wheel and axle, which is the last part. If two wheels of different diameters are attached together, a wheel and axle is formed. For example, bicycles, cars, trains, almost all machines work with wheels use the wheel and axle principle. And this is quite easy. Again, we have the same formula. Force times force distance, which is the diameter of the wheel, the bigger one. Load times load distance, which is the diameter of small wheel. And the mechanical advantage in wheel and axle is load divided by force, again the same. Example says find the required force to lift the load. And my formula was F times R, big R, is equal to load times the small r. Again, I am trying to find the force here. R given as 30 centimeter and load given as 600 Newton, and the small r given as 1 centimeter. From here I can find force as force times 30, 600 times 10. If I cancel out zeros here, force will be equal to 200 Newton. So how can I find the mechanical advantage? Again, load divided by force, and the load was 600 Newton, divided by the force we applied, 200 Newton, and that's equal to 3. Okay, that's enough for today. As I believe it's important, in the next video we will look at the wheel, axle and gears trilogy in a little more detail. Well, I don't think I need to say it anymore, but if you haven't subscribed our channel so far, please subscribe and like the video. Thank you.